Welcome everyone to the Inside Java Newscast episode 38, where we cover recent developments in the Java community. My name is Jose. I know you must be very disappointed not to see Nikolai, but don't worry, he will be back soon. Today I would like to talk to you about the upcoming release of the JDK 20, scheduled for March, what will probably make it in this release, and how the release process works. The JDK 20 will ship on March 21st, just in time for spring. If you check the status of the JEPs people are currently working on, you can get a glimpse of what is coming for this release. So let us talk about that. There is new stuff for pattern matching, for Loom, and we'll also talk a little about Valhalla. So, as Nicolas says, let's dive right in. He's so much better than me at doing that. Why do I even try? Sequence collection is an addition to the collections framework. This is amazing because this collections framework is 24 years old and it's still central to every single Java application in the world. And yes, there are still people working on it to improve it. When you take a look at what was done in the past few years, we had factory methods with list.off, map.off and the like. We had list.copyoff, map.copyoff, performance improvements here and there. A lot of things have been done. This time it's about bringing a new interface called sequence collection of E, with methods specific to collections that have a defined encounter order. You may be thinking that list of E already does that, but in fact it does more. It also gives indexed access to the elements of the collection. Sequence collection does not. So sequence collection gives you get first, add first and remove first, and the same for the last elements, get last, add last and remove last. These methods are coming from the deck interface. And it adds one method to the lot called reversed, which gives you a view on the reversed of the elements of that collection. It also adds sequence state that extends set and sequence collection, and sequence map with similar methods for maps. With that in place, linked hash set can now implement sequenced set, and linked hash map can now implement sequence map. The JEP 431 gives you the exact places in the interface hierarchy of the collections framework where these three interfaces are inserted. Two elements on the pattern matching front, we should have a fourth preview of pattern matching for switch and a second preview of record pattern matching. Both record pattern matching and pattern matching for switch now support type inference for the pattern variables, meaning that you can declare your pattern variables with the var keyword and the compiler will guess the right type of this variable for you. Record pattern matching now support nesting in the second preview feature, which is really nice. So you can now write this kind of pattern, which is great. And there is also a hidden gem in this JEP. You can use a pattern in the enhanced for statement. So that makes a third place where you can use patterns, instance of, switch, and the enhanced for statement. Now, just be careful because this will also bring new bugs. For instance, if you iterate over a list that contains a null value, of course nobody does that, then you will get an exception. Loom should deliver several elements in Java 20. First, the methods that have been added to the future interface in 19 should make it as a final feature. There are two default methods, resultNow and exceptionNow. ResultNow is meant to be called on a completed future. It does the same as get, but does not declare any exception in its signature. This is nice if you want to stream a list of futures and get their results. There is also a state method that tells you about the state of this future. The state itself is an enumeration with 4 values. Running, the future is, well, running. Cancelled, someone called cancelled on this future. Success, the future completed and produced a value. And failed, the future completed but with an exception. There are several methods on the thread class that are also made permanent. Among them are two overloads of join and sleep that takes a duration as an argument. And the last element that is made permanent is that the executor service interface now extends autoclosable, meaning that you can create an executor service in a try with resources statement. It will automatically close this executor service when you are leaving this block. We should have a second preview for virtual threads and a second incubator version of structured concurrency. And we should also have the first incubator version of scoped values. We didn't have that in 19. This scope value features was in fact the missing piece of Loom, and now we have it. Virtual threads fully support thread local variables, no problem with that. But scope values are an alternative to thread local variables. They are non-modifiable and are defined at the same time as the launching of the task. The task itself and its execution is actually the scope of the value created, and it is made accessible to all the code executed as part of this task, regardless of the thread that is executing it. Another great feature brought to you by the project Loom. Valhalla is doing well, thank you. A few days ago, another early access release has been published called LW4, standing for LWorld 4. This early access release is focused on one point: value objects. Now, value objects are objects without any identity, which means several things. First, you cannot synchronize on these objects. Second, equality is handled in a special way. You know that when you compare two strings with equal, what you're really comparing are the references to the string objects, not the value they carry. And you know that this is not what you want most of the time, because it may give you a result false when in fact the strings have the same value. Because value objects do not have any identity, comparing them with equal actually compare their values. Just because there is nothing else to compare, value objects do not have any identity. You may have in mind a comparison with primitive type. Java is not C. You cannot play with references to primitive types in Java. And you may also have heard that Valhalla may bring user-defined primitive types in the future. But value objects are not primitive types, so you should not go too far with this comparison. The benefits you may expect from that is better performances, because a value can be inlined, it can be flattened. All this makes room for optimizations. It may improve computing time, memory footprints, and garbage collection performance. In a nutshell, at this point, Valhalla defines two kinds of objects. First, you have identity objects. These are your classical objects. They do have an identity. What you have is a reference to them that can be null. You can synchronize on them, and because they are stored in a well-defined place in memory, you can mutate their state if you need. And second, you have value objects. That is, objects that are just that, a value or an aggregate of values. They do not have an identity, so they are not stored in a specific place in memory. But they may still be references, so they can be null. Comparing value objects with equal actually compare the value carried by these objects. And mutating them, of course, doesn't make any sense. Valhalla is also working on the concept of user-defined primitive types. That's a different concept than value objects, and we are not there yet. To learn more about the Valhalla project, you can follow the links down below and download the early access build to play with it. There are more things that will come from the Valhalla project, so as usual, stay tuned. And with this, I'm out of news, so that's it for today. Talk to you soon.